at Google with our moderator, Ron Miller. Thank you.
Everybody. Welcome, everyone. Kubernetes, the open source container orchestration tool, was born inside Google in 2014. You guys, I'm not telling you anything you don't know. It was open sourced in 2016, and today it's the fastest growing open source project. We have the distinct privilege to have these 4 individuals here to discuss Kubernetes with us, 3 of whom helped develop it in its earliest days, and the 4th who helps guide Google's version of Kubernetes today. So Joe, let's start with you, since you happen to be next to me.
Here we go.
Why do you think it's become so popular so quickly?
Well, it's been 5 years, so there's
That's
quick and there's
fast,
quick. I think there's a lot of factors, and I think any time you look at a project like this, I don't think there's any one explanation why something succeeds and fails. I think right time. I think Brendan likes to say that based on the experiences at Google, we kind of we knew how all the we had the picture on the front of the puzzle box, right? We had an idea of how all this stuff fit together, and I think just community, both in terms of sort of the wide set of folks that have contributed, but also, we were able to get like all 3 major cloud providers on board with Kubernetes. And so being able to bring all of that together was a big part of the puzzle too.
I mean, I think also the job of developing software had just sort of reached a point where it was too hard. Developing an operating software is too hard. So there's a real need. There was this very, very strong need. I think success is partly all of the things we bring to the table, but also was just the strong developer need that it could fit. There's still a lot more work to do there, though.
Yeah.
I think it spoke to the problems that people were really having. It brought them a new abstraction that was much more pleasant to use. And right time, you can't outweigh the cost or the benefits of being at the right place in the right time with the right ideas. But I think, yeah.
Yeah, I would say, building on what Joe said, definitely with the heritage of Borg from Google, that allowed us to stand on the shoulders of giants. But beyond that, I think the community actually really invested in making the project stable, making sure that there was a conformance program, that it had longevity, and the architecture of it was modular so that there could be an ecosystem that evolved around it that provided business opportunities for many companies.
Yeah, including yours. But you mentioned like you had the kind of head start, right? Because you were doing it inside of Google. But it must have been a huge challenge to kind of create this take it from an internal tool to a more general application where people didn't have a team of Google engineers to rely on. So what was that like?
Well, I mean, I think it was a clean room re-implementation, right?
Yeah.
It was inspired by, but not. It was built from scratch and built with public cloud in mind. Joe and I were both working on public cloud and had been thinking a lot about how people learn to use tools and how you bring them into that world. I think we were also super lucky, and someone who's not here but was really instrumental early on, we were super lucky to have the Red Hat folks join us and bring in that hey, the real world looks like this kind of experience that they brought to the table. And Clayton Coleman in particular and others were really instrumental in I think making it approachable. Yeah, I think I taught CS 101. That helped too.
Yeah.
There was a lot of skepticism inside of Google early on with Kubernetes.
Oh yeah.
A lot of hey, we got Borg. Why do we need this? I don't think Google then, and I hope the Google of today is changed. Really recognized the gap between how Google operates, what kind of infrastructure they need, and sort of what does the rest of the world need?
Right, exactly.
What does it need to be successful there?
Yeah, I think early on there's a lot of focus on scheduling as a problem, and honestly, it's the least interesting part of Kubernetes. It's how do you empower developers is the most interesting part.
I think a big factor is the interaction with the user base, which really led to many of the enterprise class features. So, we had a lot of feedback that we needed a more robust storage interface. Then we had a lot of feedback that we needed a security story, which is now much better fleshed out. Also feedback that we needed a bare metal story. So those are some of the areas where users have directly contributed to the project being applicable.
And did you
Yeah, from the very earliest days, when you look at what Kubernetes was, it was focused on the cloud experience and trying to meet customers and users where they were with what the software they were doing today, like focused on off-the-shelf open source software, had to work sort of unmodified. And these were very different than the sort of things we do inside Google.
Right. So you mentioned that it's more secure, but when I was in Barcelona in May, I was hearing about issues with container security. There was a lack of maturity there. So I'm wondering, do you guys think, do containers have a security problem, and how does the community deal with it?
Security is a journey, not a destination, right?
It's not a binary thing.
Yeah.
You have it or you don't.
Do we have a problem? No, I don't think we have a problem any more than Linux has a security problem, right? Is it as good as it could be? No, of course not. There's a lot of work to do. There's a lot of people doing really interesting, innovative work, trying to throw up new barriers, a lot of people approaching it with very different perspectives, which I think is fantastic. We'll continue to iterate on this forever until Kubernetes is no more.
Yeah, I think as Tim said, it was a purposely integrated system, which is in some ways a little different than other people run across. So we run into environments all the time where, for example, only certain people have privileges to create a load balancer. Well, you can't create a Kubernetes cluster that doesn't know how to create a load balancer. And so now suddenly by deeply integrating with the cloud, you've forced people who maybe had security by separating worlds to sort of deal with the fact, hey, a developer actually should be able to expose something on the internet, and how do we make sure that a developer can expose something on the internet safely?
Right.
So it definitely changed things. I agree with Tim. It's not a problem. It's just there's differences.
I think any engineering system, there's trade-offs, and I think that you take a different approach and a different threat model when you're building like a public cloud and you're inviting sort of hostile actors to come run right next to other workloads, versus when you're building something for an enterprise and you're worried about like two development teams stepping on each other's toes. And I think that there's different solutions for those different problem spaces. And then I think the other thing is, one of the things that has made Kubernetes successful is that it's very, very, very flexible. And I think it's similar to the Linux kernel in that case. Like the Linux kernel runs on everything from like a cell phone all the way up to like a mainframe. And it's an incredible piece of technology that it can actually work in all those situations. Kubernetes is very similar in some ways in everything from public cloud to on-premise to edge to, people are doing other crazy things with it. And with that flexibility comes a lot of choice. And that means that there are ways to run it insecure. There are, that's part and parcel of the flexibility of the system.
I think, Ron, if you look at where Kubernetes is being used now, it's being used in financial services, it's being used in retail, it's being used in highly regulated industries. And so the security aspect is key. And I think we've made a lot of progress over the last 2 years in terms of the security roadmap. I mean, there was a time when it was ABAC based, and then there was RBAC, and that was kind of the first step. But there's been a lot of progress made since then. And users are able to use it in highly secure environments.
So in terms of you with FDO and you with your flavor of Kubernetes, do you think the vendor ecosystem that's building up around it, is that addressing it in ways that maybe the general open source project hasn't, or how do you see it?
Specifically security?
Yeah.
Yeah, I think the modularity, the extensibility of Kubernetes is an opportunity for people to come in and say, I have ideas at this layer or this layer or this layer, and I can approach the problems in different ways. And you can see there's a really robust ecosystem of companies doing security and a million other things with Kubernetes through the extension mechanisms that we've built and are continuing to build and will continue to build so that they can build out that ecosystem. We knew from the beginning, we had this conversation very early, for every $1 that a cloud provider makes on Kubernetes, there's got to be $100 in the ecosystem, right?
Yeah, the ecosystem development was very purposeful, and I think it's great. I don't think it's a criticism to say that it's good that the ecosystem is developing solutions to these problems. It's intentional. We want to put the hooks in the right place. Even open source projects, like the open source projects that we're working on around policy with the Open Policy Agent, they come in through admissions controllers. They don't link directly into Kubernetes. They come in through an extension hook. That's purposeful, right? Because it means that that thing works. I don't have to go and talk to every cloud vendor, every Kubernetes install to make it integrated into their platform. It just works with this extension hook that's already there.
And there was There is an evolution. I think certain things have become standard, like, role-based access controls are standard. There are certain security defaults which everyone uses. And then there are areas that are still evolving, like, what do you use for network policy? What do you use for other types of service policies? That's area that's still, an area of innovation.
I mean, I think part of it is, even though 5 years is a long time, 5 years isn't a long time, right?
Yeah.
It's true.
Yeah.
It's been a blur.
Yeah, for sure.
Yeah. So one of you just mentioned the ecosystem and how that helps. I think it was you, and which leads really neatly into my next question. So thank you. As Kubernetes has increased in popularity, it's given rise to this ecosystem, including your company, which was sold to VMware, and and all of these different flavors of Kubernetes, like your company's version. When you create these companies on top of that base open source project, how do these companies help reduce the complexity of somebody just kind of downloading that base project? How do you get people going where maybe they couldn't?
Yeah, I don't know. I think there's a whole bunch of flavors in the ecosystem, right? Some of them are, a logging or a monitoring company who can come and say, hey, look, take this YAML file, install it into your cluster, and every developer has searchable, logging. You didn't teach the developers deploying the application anything. You just said to the cluster administrator, to one person, install this sort of daemon onto your cluster, and things like that work. I think we're also seeing an explosion in sort of the consulting ecosystem as well, as people want to, because Kubernetes got sort of combined with cloud transformation of these companies, and it's more than just Kubernetes. It's how do we do continuous delivery? How do we, shift left in terms of error detection? So I think it's a wide variety of ways the ecosystem helps.
There is a little bit of a push-pull between the project and the ecosystem. I think there's some things that it's worthwhile to actually have stuff built into the project, or at least closely associated with the project. And then other times there's an explosion. I think security is a great example of this. Like I would be, so we're investing heavily in this, standard ways of installing Kubernetes. There's a gazillion ways to do it, but we want to essentially have a bunch of standards, toolkit there. We want to make sure that's more and more secure as we go, essentially drive, better defaults there. And so I think when we look at it through the view of the ecosystem, I think we want to make sure that there's a consistent base that everybody can build on top of, and there's efforts like conformance tests to really drive that. But then I think there's a lot of room for folks to sort of build experiences on top of that, either vendors doing it or companies actually sort of building their own internal platform.
And I'll say, too, from the beginning, we tried to not be everything to everyone. We've been really clear about what we wanted Kubernetes to do and to not do, and we called it the swim lanes early on. This is where we're going to be, and outside of that is safe for ecosystem to go and do things. We've moved a little bit over the years as we see cluster turnup is a really common problem. So we adopted tools like kubeatom to make things easier, and probably will continue to extend in smaller ways. But we know that there's room on purpose for people to build up and around and below the system itself.
Yeah, I think it was around the end of 2017 that the leads got together in the community and decided that we need to define a stable core, and that core would be kept whole and stable, and that's what the conformance is defined around. But then beyond the core, and so I think of it in two axes. There's the axis of secondary layers, the services layer, the developer experience layer. We talked about CI/CD. Those are all areas where multiple companies can build experiences and can build products. And then the other axis is really sort of specific for particular verticals, solutions that are meant towards financial services or retail or certain other verticals.
But a lot of what you're talking about here is the base product and then how you can build on top of it. But what I'm trying to get at is more like some companies don't have this extensive engineering team, right? They don't have these resources internally that they can kind of draw upon. And then some vendors fill in that space and say, we're going to kind of take away that complexity of the base product. And so how does the ecosystem kind of come in that point and help these companies that may be a little less technical? They might not even be technology companies.
I think that's where vendors come in, and I think as you look at where folks are building businesses around this, it's really, we talk about, they bring opinion. They bring this curated view of like, hey, if you use this set of projects, maybe with a little bit of proprietary stuff mixed in, you're going to have a good time. And I think, bringing that opinion, bringing that sort of, that roadmap for how these things go together is one of the places where a lot of vendors do add value.
Right, and I think with a managed service like the Kubernetes service that we run in Azure and any of the clouds, it's also doing that, right? Like we don't just sort of take the latest bits and flip them up.
Sure.
We test it. We make sure that the upgrade works. We understand what's necessary to do the upgrade. Pay attention to the community to know, hey, there's a new flag. You need to set this or whatever. So I think that's part of it, and then I think also part of the thing you see with like Cloud Foundry repurposing themselves on top of Kubernetes is to say, for some people, it just makes more sense to come in at a PaaS layer, right? And to come in, or functions, like, I don't know, there's like 19 different implementations of functions as a service on top of Kubernetes. Sometimes it just makes sense to go with someone and use them to provide a easier developer experience.
Right.
And I mean, if you think back to where Linux was in, like, say, circa 2002, right? Linux was 8 years old at that point. There were 500 Linux distributions that you could get. Some of them you had to download the bits and compile them yourself. Some of them were pre-built. Some of them even had UIs. Most of them were written in TK. And over time, those things have gotten easier, and sort of some of the lower players have fallen off the map or been consolidated. I think we're sort of at that stage now with Kubernetes where it's still a little harder than it needs to be. I think there's opportunities for the core project to get simpler, but I also think the real opportunities are in the ecosystem. And you can see already really creative projects coming out of the ecosystem of how to streamline Kubernetes. How do you build the whole system into a single binary if you want to run it on your Raspberry Pi? And those sorts of projects are really creative and interesting, and they're not part of the core system, and they probably should never be. And that's, I think, the real power of the community and the ecosystem.
Yeah.
So, okay.
I was talking to a VC a little while ago. They're like, okay, how do I pick which Kubernetes companies to invest in?
Yeah.
And my answer was like, I don't know, like we already sold, so there's nobody left. No, it's not. No, my answer was that like, if you want to look for the investment opportunities, look for the things that Kubernetes enables. What are the things that you can do that you weren't able to do before because we now have this up-leveling of technology in this platform? So I think, all of us would be saying that like, one of the themes in the Kubernetes community is like, we want to make Kubernetes boring, right? Because good infrastructure is boring. It's not something that you lose sleep about. And so what that means is that the excitement then moves up the stack.
Yeah. Yeah, I think success would be that it becomes like Linux, that it powers the many other products and many other systems.
Yeah. So in terms of, if this is still complex, where do you see room for reducing that complexity and making it even easier for, again, these companies that are not Google and they're not even a technology company, they're just companies trying to take advantage of something like Kubernetes?
Well, I mean, I think, as I said earlier, managed services for sure, right? Or an on-premise person is willing to manage it for you. That's a baseline, right? You have to have, you don't want. I think we went through this phase, much as with the Linux distributions, we went through this phase where there were people at the company who really, really, really wanted to run their own Kubernetes and be the admins and back up the etcd and all that stuff. And like, I think mostly people have realized that's a bad idea, because like I talked to even the big companies and they're running 10, 15 clusters, and my teams are running tens of thousands, right? And so we're just going to have more automation. We're going to have more like mechanism behind it, right? So I think that's a big place. But then I think also these vendors and the stacks that they bring on top, that's important too.
Honestly, I think the management of Kubernetes, if you think about who are the users, especially moving into the large enterprise, those teams have other fish to fry. They have other business goals. They have developers that want to write, cutting-edge applications that'll actually move the business forward. So as far as managing of Kubernetes clusters, I think that is something that ideally is automated, through a cloud service or through some other partner that you're working with. Certainly our approach has been to build more of a end-to-end product on top of it, on top of our service, adding what we call Anthos, which adds service management and that developer experience on top.
So if you guys were looking at the startup community, you talked to investors, you were saying, What would you like to see startups building at this point, to push that forward, to push these kinds of, issues that still exist, and clearly, there's no such thing as a perfect project?
Well, I think that the biggest thing for me is that Kubernetes is great for operators, but it doesn't do much for developers. It does almost nothing for developers. And so we have to fix that, right? And that's the biggest
the larger
area
ecosystem.
The larger ecosystem. Yeah, I don't mean we as Kubernetes, but I think we as the computing industry have to fix that because it's just too hard. Like, we don't do anything to help you build a larger scale system, and it's just too hard, and people don't know how to do it, and they build bad systems.
Tools, visibility, debugging, introspection, the things that software developers do day in and day out, right? Like, if you spend 10% of your time writing code, you spend the other 90 debugging it. And Kubernetes it's not a thing for that yet. Right. And so I think that there's lots of opportunity there, and I'm eager to see what people are doing there, especially in the logging, monitoring, tracing, telemetry business.
Yeah. So I would say that one of the things that made Kubernetes successful is that it is a toolkit of things that you can put together. I mean, it's like essentially a Lego set, similar to the way that cloud is a Lego set. And I think what we find is that we need more types of Legos that help us build up. And I think we have seen folks that aim at developers, and they provide that overall experience, the big plastic toy, right? We haven't actually seen anybody complete the picture of, like, let's do Legos all the way up. And I think that we're getting there, and I think that it's, we're figuring out what the right shapes of those pieces are to really recreate that sort of all-in experience. But it's hard work, and there's a lot of explorations. And I think this is one place where, we talked about early on with Kubernetes, with the history of Google, we had that picture on the front of the box. We had that map. And I think in a lot of ways we're off the map now. Oh, yeah. And so, we're, as a community, we're having to actually figure this stuff out in some ways for the first time. Whereas, early on with Kubernetes, we kind of already had a game plan in mind.
Yeah, for sure. I think it's akin to the development of object-oriented programming languages, or even programming languages in the first place. It's like, we kind of understand the problem, and we have some sense of where we need to go, but we're really out in the jungle.
Yeah.
I think there are two areas of innovation that stand out, especially as Kubernetes becomes more popular in the enterprise. So there's certainly the developer experience, but there's also the scalability of it. And so we've been working a lot more on multiple clusters. We found that every customer has many, many clusters, and there are very good reasons for having multiple clusters. And how do you manage services across multiple clusters? That's an active area of innovation.
Yeah, that's for sure true, and that's one of the reasons why we did centralized policy management, so that you can manage a policy for all of your clusters from a central place, have one policy that gets blown out to every single cluster you have, because my observation is the same thing. And I think that's something that surprised all of us, was that we were used to these giant big iron giant clusters, and the average cluster size is not giant.
I think there's an evolution of the cloud space, though, also. I mean, I think at one point, several years ago, everybody thought we were going to end up with like 3 big worldwide computers, right, with big clouds. And I think we're finding that reality, especially when you talk to real enterprises, is more complex than that. There were these forces pulling things together to cloud, and now there's all these forces that are sort of sending it in opposite directions, like GDPR, data sovereignty, edge, risk around single vendors. So like a big part of what I think folks are looking at Kubernetes for is a way to actually start bringing consistency across a very, very complex infrastructure ecosystem or infrastructure landscape.
Right.
For sure.
I think the consistency message is really a critical message, that people come to us all the time, whether at Google or at Kubernetes, and say, I've got these disparate worlds and I need to find a way to bridge them. I don't want to teach my people how to do everything twice.
Right.
Yeah, for sure.
One of the things that surprised me at KubeCon is, and I've gone to a couple of them now, is the number of ancillary projects that have sort of developed around the main Kubernetes project. And it seems to me, as a not as a developer or an IT person, but as somebody observing, that the more you get into this, the more you need these ancillary tools. And you didn't realize that, or maybe you did. And I'm just wondering, when you were thinking about this as you developed it, did you sort of foresee that there would be all these ancillary cloud native technologies that would have to develop?
I think that was honestly the experience inside of Google.
Yeah.
I think when we talk about Borg, which was the Google system that inspired Kubernetes, you ask different teams inside of Google what Borg is, and you'll actually get different answers. You ask the Borg team, and they're going to give you a very narrow thing. You ask the Borg SRE team, they'll give you something else. You ask the average Google developer, they're going to throw in everything in the kitchen sink and call it Borg, right? And so I think, looking at the evolution of all the sort of ancillary tools that sort of got made to make the sort of the Google infrastructure system successful, it was pretty clear that we were going to see that happen, and more so, I think, in the open source ecosystem.
Yeah, I always felt that you won or lost on the ecosystem, right, as a project, because there was competition in the early days, and that ecosystem was critical. Taking people who are willing to bet their business on your thingy was critical. But I also think you look at Linux, like Tim was saying. I mean, how many packages are there in Debian? Like, I mean, thousands, right? Every single one of those is its own little software project, right? So, like, that's just the way computing and open source works.
And everything kind of one thing leads to
it's
another.
the bazaar. I mean, the cathedral and the bazaar is sort of like the canonical example at this point, but it is the bazaar. It's a lot of different people doing little things.
I'd say for sure it's yes and no. Like, we knew that we wanted this ecosystem to have 1,000 flowers bloom. What we actually got was like 25 billion. And now we're sorting through which are the good ones and which ones are not the good ones. And it's very
in some ways, who are we to say?
It's organic. It's happening, right? It's this sort of Cambrian explosion of ideas. People talk about the adjacency of the possible, right? Like, we didn't know what we could do until we got to this step.
Right.
And a whole bunch
well,
of
that's what it seems to me as, like looking at it, each kind of leap forward creates this need for some other tooling that, it just wasn't there, and then somebody creates it.
Exactly.
Right?
And then that opens a new door, and you step into that room, and
like
there's new doors there.
But it's also solved a whole bunch of problems that are no longer in need of solving. Right? Like, nobody thinks about how to distribute their binaries around the world anymore. It's a container image and a container registry.
Right.
So I think you do have that explosion of new stuff, but you also have these problems that are now done. Right? And that's good.
Yes. Yeah, I think the modularity led to the ecosystem. I think it was by design. I actually think that there's another layer of ecosystem that is yet to happen in Kubernetes, which is like using the Kubernetes pattern or the Kubernetes API style, the declarative API and the controller. It's not really a T-shirt style. It's a style that's associated with Kubernetes that other projects can adopt.
Yeah, it turns out we did something we didn't really plan to do, which is define a whole new framework for building APIs.
So I have a kind of complex question. We only have 1 minute left, but how do you see serverless and Kubernetes working together?
Yeah, that's totally coverable. All right, so I'll just say, these are not either or. These are and. I think one of the talking about those Lego bricks and being able to actually sort of build up. I think serverless and serverless is not one thing. It's probably 3 or 4 different things or even more, but those are some of the building bricks. One of the things that I think when people look at Kubernetes, they want to be able to do these things like serverless, but then, now I have to do something, where I'm doing some long-running math. It doesn't fit in the serverless. I don't have to go back to raw VMs to do this. I can actually drop down to something that's much more approachable. Right. And so I think it's going to be part of the solution, not an either-or type of thing.
I think the interesting thing when we started building serverless container infrastructure, raw serverless container infrastructure into our cloud, what was interesting to figure out was that Kubernetes in its core, in its code, is deeply addicted to machines.
Yeah.
Like, there's all kinds of implicit assumptions that are baked into the code that assumes that machines are there. It will be interesting to see how we tease that apart, because I don't think that most people want to see virtual machines in the future as a concept. So.
I would love to hear you guys, but we are out of time. Thank you so much for a great discussion. I really appreciate it.
Thank you
for having us.
Thank you.
See you guys.